ladies and gentlemen. I think the next 15 minutes, I'll just try to take you around what we are trying to do in Tamil Nadu, basically using technology. When we speak about technology, we speak about AI, we speak about blockchain, we talk about machine learning, etc. But unless these technologies actually go to the society, it benefits the society, all these technologies of no value to human, actually. So how do we try to bury and really put into use effectively is the one which we try to do. And we are trying to do a small pilot to start with, and then take it forward. This is what we call the first use of AI in really building up for the societal cause of a good public governance. The first step, what we try to do is, how do we develop a digitized connected district? What is a digitized connected district? What we try to do is, today, whatever is happening in the district, most of the activities are all manual. Like every touch points, can we not digitize it? So every schemes, monitoring, tracking, evaluation of the schemes that is happening in each district. Can we not have some sort of a digital thing brought into a common platform, which means a district collector sitting in his chamber should be able to know everything that is happening in his district at a touch of a button. So we may even put a number of IoT devices across the district so we can know how many vehicles are moving. It's a real-time tracking of vehicles. We will know what is the food crops, that is, what is the grain that has happened, how much utilization of fertilizer. Even we can even link it to the GST, how much GST collections have happened in a particular district. What is the amount of taxation you have collected in a particular district. And even we are planning to link some of the CCTV cameras, everything is available, where we can even predict some chaos or a commotion that is going to happen. So can we not use such a platform? This is going to be a real-time, on-the-fly management of this data. That's what was actually planned. Of course, we did a lot of study about a number of countries. As you can see, it's a snapshot of whatever has happened. We took something from the Singapore model, the education one, or the Chinese model on the social services, or we took some the licensing inspection from the New Zealand. Like this, we went around, saw what were the best practices that are available in the world, and then we tried to pitch in some of the key points of it into the state, so that to say that to have a real-time validation of some of these available really for the social cause of development. So once we have such a development happening, so such huge amount of data that is coming in, right the morning we were talking about this HP server lakes, we are also planning to develop server lakes, where the real time of data coming from each of these districts, there are 38 districts across in the Tamil Nadu state. So the data is collected from all this, every district, it is sent to a common pool, a common server lake, where all information analysis happens on the fly. So the AI analytic, we are trying to build a platform, an application platform, which effectively does the same thing. So this is the architecture of a smart district architecture, which we think we can see in the left-hand side. We can see that whatever data that we take from this district, sensor that is available, sensor data, or it could be existing data, all this could be assimilated, ingested into a real-time streaming engine that happens in. And then, of course, we have a centralized platform, which actually stores and processing, everything is done on the fly. And the most interestingly, we try to do AI modeling, building on the fly. Because, now we found that we cannot have a common golden model for each case. For each case will be a different model. So on the fly, even the AI model will be changed accordingly. So we'll have a proper model building, training, and scoring that is also happening, which all leads to a very, very interesting concept of developing digital twins and intelligent displays, which means, in a real-time basis, a district collector will be able to even simulate the condition, that is what is happening. Suppose there is a flood or there is a cyclone. We will be able to virtually simulate this area and then see what is going to be the impact of a particular calamity that's going to happen, and we can take preventive action. So that's what the dream we have. We put in such a system. Even in the processing power, if you know the amount of data that is coming in, an amount of 1 million devices being the data processed on the fly and then articulated is going to take a real time. We are even trying to have, can we use a bit of quantum computing there? So we are talking to some of the firms on the cloud platform to see, of course, 64-qubit computing, which can try to do this particular aspect. With this effect, what finally we want? We would have generated what we call a centralized database of all the data that is available. Once we have such a data available, we do a real big data analytics on the fly. Most interestingly, for the citizen point of view, we wanted to create some sort of a complete metaverse environment. You know, the citizens will, so whatever type of web portal you develop, you ask this, whatever web applications you're going to develop, unless it is going to go to the common man, it's not going to be of any use actually. So we found that the rural population requires an easy to access of these facilities. So the citizen walks into a room like an enclosure. In the enclosure, it automatically starts talking to a Havadar unit. What is the requirement? Suppose he says, I need a document or land document or something like that. And then it says, these are the documents you need to place. The citizen places these documents on a scanning machine. It automatically scans and immediately prints it out and it can give. That sort of a complete metaverse environment on a citizen portal. We are trying to bring it. This can also help in prevention of frauds, addressing grievances on the fly. So we have a lot of ambition we are having on doing it. This we wanted to integrate as an API across all the other applications that are already available. Most interestingly, these IoT devices, like for example, every acre we try to put the monitoring devices, what is available in real time, say the soil, temperature, humidity, plus age-old data. We are also having 30 years old data. Can we not put those data in? And then assimilate and see, exactly predict which crop is which good for which point of time, and what is going to happen in the next few months. All these predictive things will be happen, and most importantly, we are also planning to develop some sort of a virtual city. 5 virtual cities we bring it on a portal, where we say that in this virtual city, if a citizen goes, he'll get every information on the particular city. For example, he can get information, is there any congestion in a particular area? What is the crop pattern, rainfall patterns, X, Y, Z? And suppose there's a flooding, you can say if the flood is happening, which street is going to be flooded, what are the effective measures to be taken? Almost everything virtually on a real-time scenario. That is what we are visualizing. For this, all these things happen, we cannot go for a off-the-shelf data or product that is available. We cannot buy a product from X, Y, Z and start implementing it. It's not possible. So we are trying to develop our own stack. Of course, with the help of the data that is already available, with the help of whatever ready-made software is available, how do we further tweak it? So we develop our own AI stack and we build the AI platform also for the state. We are in the process of building it. Probably we will bring in advanced languages, a Julia platform or etc., where we can really try, because the amount, if we can visualize the amount of data that we try to do on the fly, that's really critical. That's not possible when we start developing that. Of course, we have sensors, and then we put the next generation power systems, ecosystems, etc. So all this will lead to a very, very interesting, futuristic thing which we can think, what we can call a real smart grid that we can develop. Suppose we can have a citizen grid. So whatever information the citizen, you imagine the entire state, we have a 4 grid. We have a customer grid, resource grid, process grid, and the economic grid. Whatever the citizen wants, he taps into the grid, and automatically all the data that is required is automatically given to him or taken from him. It's a two-way communication. So, and the same applies for resources. See, the prosumers. I think you heard about this prosumers. Suppose I put my solar energy on the top, I can even produce electricity, and I can even consume electricity. That's what we call prosumers. So that will also be one of the resource grid. And we have a lot of process grid, economic grids, etc. This sort of a 4-layer grid, which will effectively bring in real benefit to the society, is being planned out. How we plan to do is, again, we wanted to build it on a completely distributed ledger platform, which is our own blockchain-based network. We call it DLT platform, where we make it as secure as possible. So all the districts distributed on a DLT-based security base with a clear private cloud kept at the center, and then the citizens could interact easily among themselves for all these variations. Of course, all this, that I'm sure Kerala and every state is having this BharatNet network. So we are trying to bank on our own this BharatNet network to reach these villages. So we have a backbone completely, gigabit internet running, and then over which all the data could be easily pushed using this BharatNet network. That's the plan. This is the overall, just a bird's eye view of the DLT architecture. Very interestingly, you can observe the entire art and soul of the entire process. We have made it as a security services because everything should go on a security area. So if you see here that we developed some sort of a trust services, something of the blockchain stuff, where everything is documented and authenticated before it goes away. So whether you get whether the customer puts in data, customer takes data, whether the data provider, the census data, the data from different offices, external flow of data, everything happens only through the security. So that we are very, very sure that the amount of information that is shared is perfectly protected, and then only authenticated information goes out and authenticated information comes on. And we are also trying to build what we call deep APIs access, which also we are planning to open up to the consumers, to the citizens, where anyone could even start building a small app on your own using this data set, which will be useful for the citizens. That is also we are exploring how to come. In short, this all puts together a snapshot of what we think the real touch areas on the phase one, which we are trying to implement, is the mobility, the infrastructure, agriculture, education, commerce, and health. Each one of these is the test points. For example, in agriculture, what is the farm data we have? The monitoring, the soil type, soil ingredient type, what are the subsidies being given? What is the sale of furniture? Sale of fertilizer? And what is the amount of taxation that is going to happen? Amount of fertilizer that is being used per acre? All that stuff. Similarly, in each one, suppose you take health. What is your personal health data? How many people are visiting the PSCs? What type of data? What are the possible causes? This we did it in a place when we was earlier working in Uganda. There was a particular problem of these viral diseases coming in. So we were able to predict the outbreak of these diseases if we are properly having the data available. So that is a very critical thing. So if you have the age-old data available, we can even predict what is going to happen in a few months' time, and that will be of great help. So this is a few areas which we are targeted in the digital TN platform itself. This is the small platform which we think of building in the state. We can see that it is built on its own network, where we have tried to see, we have our own infrastructure, we have proper storage. The storage has cold, warm, hot, all types of storage is available. And very interestingly, we put in a computing area that takes care of majority of the aspect. And then the most important, the moment whatever data comes in, it gets stored, and then computation happens, and on the fly, the data could be taken and extracted, be used. So for example, an agriculture department comes with some data, the data is put in, it is done on the fly, the analysis has been, whatever type of data they want, the reply is again sent back on the fly. So irrespective of the particular type of departments, this will act as a heart of the entire system, where the AI modeling and the engine automatically changes according to the requirements on the fly. This is what we are dreaming to put. So this is a simple snapshot of the secured ledger which I told, how we actually put the state's portal and the district portal properly in a proper packed ledger. This is what we call, I'm sure the other terms, this is called the blockchains architecture, where we can keep improving on this architecture, but we just chose only these layers to be put in with basic on Aadhaar-based authentication, identification on a blockchain, consent framework, even smart contracts, APIs, etc. That's how we have totally built the entire network, and using the existing network. We even have a district created databases, and now we can use these databases effectively. So this is a very, very interesting thing. We can see that how we can marry both the function of ledger and library. So I get what are the data available. I put the data. As I told you, security is the key of it. I assimilate all the usage data, say for example, power usage, medical information. These are all very critical, very, very critical data. So this should be properly put so that you put a ledger function for the central management of data. When you push it out as a librarian function, it becomes whatever data is properly processed, and only the appropriate data requested is sent to them. So that is what you can provision of processed data in a usable format alone is being given. That is what we are trying to target. Once we have such an interest, if we can see this thing, different schemes, taxes, whatever data, the spatial data, what we get, we do an analysis, and then it goes on a real-time and intelligent model. It will be a completely, display is also made intelligent. An intelligent display is made available. Even you can talk to this. Suppose the collector can ask, what is the rainfall pattern in the next 24 hours? Or what is happening in this particular village? What is the amount of fertilizer utilized? It is just talking. No need to even go and enter. The sort of complete interactive, intelligent display is also being planned, which will be really useful. For which, again, a very critical thing, I just put one slide to show that to build all this, essence is how do we do profiling? Profiling is a very, very key factor of the entire thing. So we need to do digital profiling of each one. So for each of the aspects which we mentioned, we need to put clear digital profiling, which will be added value to each one. And with all this is available, finally, we have this AI engine. This you can see that whatever we talked, now it's a reality. Suppose you have a disaster that's happening, using this AI service, I will be able to simulate this disaster and then see on a real time what is going to happen. Create virtual cities, and we can say, suppose a flooding is going to happen, what are the effects of it? How are we going to protect ourselves? What are the measures needs to be taken? Well in advance, within 24 hours before, we can even plan things. We also put in a module for 3D mapping of the complete environment, natural environment, climate pattern, the congestion, even the granary storage. That's already another interesting area. Because of time, we cannot discuss further on that. That's a very interesting area where storage of grains is another very critical aspect. And then wherever possible, use these drones, use an efficient, energy efficient infrastructure, flood mapping. Of course, when all this we come, the most important thing is how do we do this assimilation of data on the fly, get the data. That we try to build on our own, AI application Flutter using Julia, etc. And then we can go further on it. This is in short, what is our vision. We have started with a small project, a pilot, and we start building the building blocks of each of it. This is what we can say a dream of really using technology, how I can take the technology to the lowest end of the rural people unless it benefits the society. Unless technology benefits, all this technology is of no use, which we are trying to attempt. I request over here around to contribute whatever bit they can in building this journey. Thank you.